Good afternoon, everyone, or good morning, depending on where you are in the world. Thanks for joining us for the third Gradle webinar, I believe. I believe this is the third. There'll be many more to come in the future. So my name is Luke Daly. I'm an engineer at Gradleware. I spend most of my days working on Gradle itself, as well as delivering trainings and talks and those kinds of things. So my email address is there. If you want to jot that down, and if any thoughts come to you after the webinar today that you forgot to ask, feel free to email me. I'm located in London, so it's the evening for me here. And moving along, the content that we're going to be going through today is available right now from GitHub. You can download a zip file which contains the slides I'm going to be using today in HTML and PDF, as well as all of the example code that we're going to work through. So that's available right now. If you want to grab that and to have that on hand as we go through it, or grab it later, that's up to you. So that's the administrivia out of the way. Let's get going. So what are we here talking about today? Well, the title of the talk is Administering Your Enterprise Build Environment with Gradle. And what does that mean? Well, we need to back up a little bit and talk about automation in a more general way. So at the core of Gradle are some philosophies that are highlighted by these points here. We believe that only the simplest of software can be built in near identical ways. Almost all software requires some kind of configuration or some kind of uniqueness about it. And that can be applied on different levels. We'll see that. So while software is different, we also learned over the last couple of years from various build tools that the idea of convention over configuration is very helpful in the build space. While there are differences, there are a lot of commonalities. And we want ways to express those conventions and apply them in a general way. However, rigid conventions inhibit our ability to innovate and automate efficiently. So if the conventions that are imposed on you aren't flexible or aren't malleable enough, they can actually prevent you from doing the kinds of things that you need to do. So while conventions are good, they also come with a certain cost that you need to be aware of. And modern automation in the world of continuous delivery or frequent delivery needs to be ambitious, effective, and pervasive. You really need to automate everything. And you'll find that the more you try and automate, the less applicable the general out-of-the-box conventions become, because that kind of automation is very custom to the environment you're in, and you really need it to do very specific things that don't apply to other enterprises. So while you have all these custom requirements, you don't necessarily want to give up on the benefits of having conventions that can apply. That you just may find that the conventions are somewhat localized to your environment. So whose conventions are we really talking about? Gradle out of the box can only really deliver conventions that are quite generally applicable. So we have conventions for building Java projects, structuring Java projects. And you might want to do a few things there. You might want to extend the convention and say that all projects within your enterprise use checkstyle for static analysis. That's a rule that you want to impose. And Gradle can't really impose that out of the box. That would be too domain specific. We can't enforce that everybody uses checkstyle. But you may be able to in your organization, and you may want to enforce that. On the other, so that's extending a convention or tightening a convention. You may want to replace some of the general conventions that Gradle ships with. So one of the conventions that the Java plugin has is that we pre-configure a main source set. Now that may be completely meaningless in your environment. Your software may be much more complicated and comprised of many different types of main source. So you may want to actually undo those conventions and come up with your own. And we'll talk a little bit about how with Gradle and our flexible and stackable conventions, you can dial some of those things back. But today is really going to be about talking about the kinds of how you can deliver your custom conventions. First, develop them in some kind of shareable way, and then apply them across the board. We talk about Gradle as a toolkit. So it's a collection of tools like Ant. Ant ships with task definitions to do a bunch of useful things, compile code, run tests, those kind of things. But unlike Ant, inside the Gradle toolbox are also a lot of things that exist for enabling standardization, reuse, and overlaying conventions. There are things like plugins, plugin stacks, configuration rules, DSL extensions, and init scripts, and a few other things that exist just to enable this kind of standardization. It's a big part of the Gradle message, is that you should be aiming to be able to standardize and reuse logic that you develop as much as possible. And we'll be digging into each of those points during the course of this webinar. But it's a lot of the sort of plugins and interesting innovations in the Gradle space are really around this, enabling this kind of standardization and reuse. It's a very big part of it. So what are the deep technical points we're going to be through today? We're discussing the deep API that Gradle has and the implications of that and what that means. Configuration rules, going through those in detail. Talking about plugins, how they relate to this particular case of trying to apply standardized configuration across many different projects. Init scripts, what init scripts do in the Gradle lifecycle. And we'll talk about the idea of custom distributions. So that's taking Gradle and customizing in some way and applying that customization uniformly across the enterprise, or maybe towards a subset of the enterprise. So the deep API. Many aspects of Gradle are highly configurable. There are many, many hooks in places that we put there to enable either monitoring, configuration, or enforcement of certain configuration. So it's something that you just kind of, when you want to do something, have to start digging through the documentation, the API, and find the appropriate hook to do things. And we'll have a look at a few examples. The examples we're going to be going through the intricate details of the API we're touching and not the focal point. It's more this idea that these kinds of hooks exist and the way you can use them to do different things. So the first example we're going to run with is, how do I enforce that no one can compile against Hibernate? So my enterprise, for whatever reason, I want to make it an error condition if Hibernate ends up on the dependency graph. Somebody tries to make software that compiles against Hibernate. And I don't just want to silently ignore Hibernate and kick it out of the dependency tree. I want this to be an error condition. So how might we do that? We go to the first demo. That's the wrong command. So here I've applied this configuration locally, and towards the end of the webinar we'll see how you could take this kind of thing and package it and apply it more generally. But here's an example of the kinds of API hooks that exist. So we have the compile configuration, which is where we're going to declare our compile dependencies. We have a hook here, incoming represents the incoming dependencies. I can add a callback after this is resolved, and then I can go and inspect the dependencies that were resolved. And here I'm just going through, and if any of them have the group Hibernate, then I'm going to throw an exception. So let's go and run this. Don't have any source. Now, if I run Gradle dependencies, that will trigger a dependency resolution. So I've only got commons lang on my compile class path, that's all fine. Commons lang doesn't depend on Hibernate. If I add Hibernate to the compile class path, sorry to the question here. Okay, moving along. So I have, now that I've added Hibernate to my class path, I get an error. So example of using that kind of hook. And that's, I was adding Hibernate directly. If I have a dependency where it comes in transitively, I also get that error. So it's a rather deep hook to enforce that kind of rule. Another example, how do I verify the existence of a test task? So I may want to have a rule that every single project in my enterprise must have a task called test. So developers know when they work on a new project, they can run the test task to run the tests. It might be a rule that I want to instate. So it's another example of the kinds of hooks that are available. I can register a general after project hook on the Gradle object and then use the project model to go and inspect and see what tasks existed. So I have full access to all the information that Gradle has. So I can do any kind of verification on the state there. Again, this is just local to the one build, and we'll be talking about how to make this apply it more generally. And again, all this demo code is available in the zip that you can download. So it's a deliberate design philosophy of Gradle to give you all of these kinds of API hooks to enable you to do the kind of configuration, customization, and standardization that you might want to do. We can't predict all the ways that people are going to need to use Gradle, or the kinds of rules that they're going to need to enforce for conformance reasons or personal style reasons, or for whatever kind of reason. But we want to give you the ability to do that kind of thing. So there are many, many of these hooks around. And if you haven't had much experience working with kind of the more obscure parts of the Gradle API, you can think of it as structured, the Gradle API as a whole, structured like an onion skin. Most build users operate at the top level, programming at the DSL, working, everything looks pretty much like example code that's out there. Then at different points, you can get a little bit deeper into the Gradle to get deeper into the mechanics to customize how it works at a deeper level. Once you start doing that, you'll start to see new classes and new data types that you don't typically work with. That's just kind of the lower level details of working with it. And if you're getting to this level, if you find yourself reading the Java doc, it doesn't necessarily mean that you've done something wrong. Everything that's published in the Java doc and all this API is intended to be used by Gradle users. It's not internal stuff. If it's in the Java doc, it's there to be used. So it's a very good idea to, once you start sort of driving Gradle a little bit harder and trying to customize it, get a little bit familiar with some of the core types and the kinds of things that are available. You can browse the Java doc online. It's available, and it's also available in the Gradle distribution. But I just want to make this point clear that it's perfectly fine to be using these deep hooks. That's what they're there for, and doesn't mean you're doing something wrong. Of course, use the higher level abstractions if you can, but they're not always applicable. So moving from the deep API onto configuration rules. So Gradle provides many ways to configure objects now and in the future. So what you often want to do is configure things that you don't know about, especially if you're trying to impose standards on quite a global level, to say that all Java projects that have a test task should have a certain kind of configuration. You need to be able to do this in a kind of a forward projecting manner. This is what configuration rules are all about. So the first example we're going to walk through is, how would I add some configuration so that all test tasks in all projects would be run as parallel as they can. So we're going to run as many parallel forks as we possibly can. So moving into that one. So here's our example code. I just have a very simple Java project with some test source, a bunch of test files in here. Oops. So I've applied the Java plugin, which gives me my test task out of the box, but I've also added a custom test task and wired it up to use exactly the same source. So my requirement was that I wanted to configure all of the test tasks to run in parallel. I've just got a simple calculation here, but to calculate the number of cores I have available and use that as the value. So my first attempt might be to configure it this way. If we go into this project, right one. If you can see my CPU meter up here, you'll see it pegs out and runs quite fast. So the test task is running in parallel, but what about my other test task that I added? Actually, it was faster that time because of the compilation, but trust me, that didn't run in parallel. So, but what I want, if the requirement was to make all tasks run in parallel, I can use a configuration rule, which looks like this, to say that all tasks of this type should have this configuration applied. No matter how many test tasks exist, what their names are, how they're configured, I want to apply this configuration to all of them. So I run, just clean this out so it runs again. Incremental build doesn't get in our way. That's quite a bit faster because it's now in parallel. So the idea of these configuration rules is being able to apply configuration in a general manner to one or more objects. And it even works, I mentioned that these configuration rules can kind of reach into the future. If I move this bit of code up here, before I create my other test task, it still applies. I need to move this up. That still runs in parallel, it's still very fast. So this actually says all tasks with type test that exist now and in the future. So you don't have to know the project structure to apply this kind of configuration rule. If there are no tasks with that type, then the configuration doesn't get injected. Another example, how would I disallow Hibernate from being a dependency at all? So previously we blocked it from being a compile dependency, but now I want to say that it's not allowed to be used for testing, not allowed to be used at runtime, for anything like that. So I'm going to take the same code we had before, and I can use this all method here. We'll talk a little bit about more about this in a second, but what this means is that to all of the configurations that exist in the project now and in the future, apply this configuration rule. So this is exactly the same code we were using before, and that then allows us to have all configurations have this rule, so it can't come in anywhere through any angle. To show that works, around Gradle dependencies, I have a test dependency here that's going to pull this in. I should see this throw an exception. It does. Complains that it found a Hibernate on the test runtime configuration. So we went from applying a rule to a very specific thing that we had to know that exists to be able to apply it much more generally using a configuration rule. The magic to that was, to make projects open, was this all method. All of the configurations that exist now and in the future. Don't forget, feel free to ask any questions at any point during the webinar. So configuration rules are based on two Gradle core types, or really one, and the named one is just another variant. But if you're looking at the API documentation, you'll eventually dig down and find this domain object collection. It's the guy that kind of powers all of this stuff. These guys have the characteristic that they are live. I can kind of show that in this example. I'm creating a new one of these collections. You'll never do this in Gradle itself. We'll see that a lot of the core types that you've been working with in Gradle are of this type already. But for the sake of this example, we're going to create our own. Numbers, I have 1 and 2 in there. This is what the collection contains at this point in time. I can split off a collection of even numbers, and that is all of the numbers in there that are even. If I then go and add something to the root collection, here, it also appears in the derived collection. This is a little bit different to what we've been looking at so far with applying the configuration rules, but hopefully it illustrates the characteristic that these collections have, that they're live, they're connected, and they can kind of reach into the future. And you typically don't go and create your own collections of this type. What we'll see is that a lot of the existing Gradle objects are already these smart collections. So if we look at project.tasks, we have a look at it in the API, we can see that if we dig right down through the inheritance hierarchy, it ends up inheriting from one of these smart collections. So all and matching and all these methods that I've used so far are available on project.tasks, project.plugins, configurations, repositories, source sets, and there's a bunch more. These are just the most interesting ones. So I can apply configuration rules to any of these guys. So some of the common use cases. So the three main methods that you'll work with when dealing with these kind of collections is all. So you want to run some code, some configuration code against all of the objects that exist now and in the future. There's a when object added that only runs when new things are added, and of course a when object removed as well. Quite a bit less useful, but it's there for completeness, I guess. We do use it in some cases. So that's pretty much In terms of standardization, all you really need to know about smart collections and configuration rules is this idea that you can attach configuration to happen on objects in the future. And when we work through this example, we'll see a good case for this. Just checking out the question. So the question is, when you add objects to a domain object container, can you tell after the fact which one was added first? The answer is it depends. Depends on the actual type. So most of them are sets, so they have no inherent ordering, but some of them are lists. So for example, project.repository is an instance of domain object list. So it does have ordering. So it has all the list methods, and you can query for what's in the container and at what index. So it really just depends. So let's go have a look. We'll see that it ends up inheriting from named domain object list. But most of them are sets. They don't have, so task, for example, doesn't have an order. Cool. All right, moving on. So plugins. So we're going to be sort of putting now taking these general rules and putting them into plugins and seeing how we can sort of push these plugins around and reuse them. So plugins at their heart are just reusable build script code. There's no special functionality that only plugins can perform. They typically serve a different kind of role, but it's important to note that there's not a kind of plugin API or things that only plugins can do. This is good for a number of reasons. One of the most important for what we're talking about today is that you can start off these configuration rules very locally inside your build script, and then as they become more generally usable or you want to increase their reach, you can move them into a plugin without having to redesign them, refactor them, or learn a new API. It's exactly the same. So things that plugins can do, and I talk about these as two different points. Plugins can add new capabilities to Gradle. So a plugin might add the ability to compile CoffeeScript code, say, for example. So that's the CoffeeScript. There might be a CoffeeScript plugin that does that. And plugins also might overlay conventions as well. So these are two separate things. So the Java plugin, and we'll see how it does this, is actually comprised of different plugins. One that adds the capabilities and another that actually adds the project convention on top. This idea that there is a main source and test source that tests the main source. That's a project convention. And these two things should be kept separate. The reason being that if the conventions don't apply to you, you should be able to opt out of them and still use the tools. So that's if you're in a very heavily customized environment, this becomes very important that plugins don't lock you into their conventions. You should be able to escape them. So plugins that add new capabilities are out of scope of this particular webinar. We're going to be focusing on the latter, plugins that add conventions and configuration. So we will be scheduling a webinar on this topic soon. There will be one in the future that will go into how you develop good capability or tool plugins. So just keep an eye on gradle.org/news for that, or the forums, any of those kind of mediums, and we'll keep you updated. Also, the second Gradle book that is coming will also help in that. Okay, so adding and extending conventions. So plugins that configure the projects to do some useful work by adding tools or configuring existing tools, so taking things further. So you might want to build on top of the conventions from the Java plugin, or you might want to scrap them and build your own completely. So they typically provide defaults or enforce standards. Enforcing standards is very important for some people. For others, it's really about just providing defaults so developers have to configure less, so your build scripts can be more concise. So the example kind of conventions that we're going to install today with what we're going to work through, we're going to, by default, add JUnit 4.10 for testing, say that we're just going to use that across the board. So I don't want to have to manually specify that in each build. I just want to apply a plugin and get that. I also want to create the concept of integration tests. So in all of our projects, we break up our tests into our fast running unit tests and slow running integration tests. And I don't want to have to configure that for each project. I want to apply a plugin and get that. I want to configure that dependencies always come from our corporate repository. I don't just want to add the definition of that repository. I want to enforce it. So if anybody tries to use a different repository, they get notified. In our case, they'll get notified and we'll just won't let that happen, or you could make it an error condition, so you threw an exception, that kind of thing. And another one, just for completeness, is that we're going to enforce that all source code is compiled in a Java 1.5 compatible way. So again, we're not just going to pre-configure that, we want to make that a standard and enforce it. So if somebody tries to deviate from that, we're going to make that an error. Before we jump into some code, a little bit more about plugins. So plugins can be packaged as either scripts, just like a build.gradle file, that's a script, or as objects. Script plugins are just .gradle files and they look and feel exactly the same as the build.gradle files you've been using so far, but you can call them whatever you like and pull them in, and we'll see that. Object plugins come in a kind of object wrapper, but they're compiled and they're on the class path. So both of these are shareable. They have sort of different trade-offs, and we'll talk a little bit more about that as we look at how they're structured. So let's have a look at a script plugin. So I have here, just ignore this line for a second, we're going to focus on this one. I have a script plugin here that implements the requirements that I just spoke about. So the first one that was going to use JUnits, we're going to add some integration testing support, Java 1.5 compilation, and the corporate repo requirement. So let's start with this one. How is this working? Well, here's the definition of my corporate repository, and I'm going to attach to the repositories container a configuration rule that says, for all the repositories I want to run this bit of code, if it's not a Maven repository and the URL isn't, or the URL isn't our corporate repo, then I want to log a warning and remove it. So it's not an error condition, but we just get a diagnostic message that somebody tried to add another repository and we just want to remove it, not allow it. And then we're going to go ahead and add a corporate repository in, so people don't have to do that. So that the repositories block is available, that's core Gradle and available in all projects. The rest of what we're going to do only applies to Java projects. So what I want to do here is I want to wrap all of this configuration in this plugins with type block. So this will only fire if the project applies the Java plugin. So if it is a Java project. Because what I want to eventually do is have this code run against every single build that gets run in my enterprise, and I may have a build that's not a Java plugin. So this functionality only applies there. So to add JUnit 4.10, that's pretty straightforward. We just add the dependency to the test compile configuration. For integration testing, also quite straightforward. We just add a new integ test source set, and the Gradle will take care of configuring so that the source should live in source integ test Java, that kind of thing. It has a bunch of defaults that it sets up for you if you do that. I also want to say that our integration, we want to inherit all of our test dependencies for integration testing as well. That's what this is saying. And I'm going to go ahead and add an integ test task. So anybody applies this plugin, they get integration testing out of the box. And here we're fulfilling the Java 1.5 requirement. This is how we set with the Java plugin what the source compatibility should be. But then I said I wanted to enforce it, not just configure it as a default. So here I'm adding a configuration rule for all of the compile tasks to add a do first action that actually goes and validates that the source compatibility still is 1.5. So this is guarding against the case where somebody has applied this plugin and then they've tried to manually change it so that it's 1.7 or something else. And in this particular environment, we absolutely have to build with source compatibility 1.5. So we want to protect against somebody accidentally changing that value, or perhaps another plugin trying to do that. So that's the implementation of our plugin. And to bring that in, we can just use this apply from statement and bring that in. So that will just, it's just like this code in this file existed right here. And that's probably in this context really only useful for developing these kinds of standards. What we want to do is apply this in a more general way across different projects. And having this file checked into the source tree doesn't really help us there. But what you can do is actually apply the plugin from a URL. and this can be any URL as long as it's publicly accessible, and it works exactly the same way. So this is pointing at the source code for this talk is available on GitHub, and this is just pointing at that exact same file at GitHub. So let's go ahead and run it and see some of these rules in action. So if I now run Gradle, well, we should see, I'm trying to add another repository in here. So we should see some kind of warning about what task do I want to run here? Let's run classes. So I see my warning that my plugin installed saying that this repository was removed, only this repository is allowed. There's our plugin taking effect, and we're applying this from the URL. So you could just have a HTTP server somewhere serving up your script plugins that define your standards or your defaults, and then pull them in this way. And if you're for versioning, you can just have your own kind of versioning scheme within the URL. So if a new version becomes available, you rename the file to version 2, something like that. It's just a URL that it pulls down from. So that's quite a useful way, quite a quick, easy to edit, lightweight way of applying configuration across different projects. That's a script plugin. I'll just for completeness, let's show what happens when we try and compile something. Do I have any source code? Yes, I do. So if I try and run Gradle test, I get a warning that something tried to change the source compatibility to 1.7, and we require 1.5. It's got a question here. So the question is, a very good question, are the remote script plugins cached? At the moment, they are not. They're requested every single time. It is something we're actively working on. We've got some work to do in our dependency management infrastructure to reuse the cache for these kinds of scripts. So right now, no, it's not. They're downloaded every single time, but very soon they will be cached, and you'll be able to cache them in the same kind of way as normal dependencies. They'll be configurable, be able to expire them, that kind of thing. So say check every 24 hours, that kind of thing. Okay, that was script plugins. So another question. Now the question is, can you use apply from within a build script block? Yes, you can, but it's a little bit different to what you might think. So you want to apply some kind of consistent configuration to a build script block. There's a different syntax for that. You would have to do something like so that's how you would need to do it. If you want to, we can go into that a bit more detail in the forum. If you want to do that, post a question on the forum and I'll keep an eye out for it and we can talk about that a bit more. But that will work. Okay, so that was script plugins. Let's move on to object plugins. Yes. Okay, so now we have an object plugin, and in this case, we're leveraging Gradle's ability to embed a project within another build. So we have the special build src directory inside our project. And Gradle sees that and treats it specially. What it does is it compiles that, expects it to produce a jar, and then it puts that jar on the class path of the build. So in here, I have a corporate plugin, and here we have the code that we were using before. So we have exactly the same rules we're enforcing. There's a repository rule, etc. They need to be recoded slightly to deal with the fact we aren't in a DSL anymore, we're in an object, but the code is largely the same. There's a few extra project dots around the place, but I haven't had to redesign anything. As I said before, it's exactly the same API. So I've moved it into that. It's a very simple wrapper. There's one apply method. You just put your code in there and away you go. So I've got that. So one reason you might want to go down this kind of route is that it becomes a little bit easier to test. So I now have my logic inside an object. I can use traditional Java unit testing to verify that it does what I want it to do. In this particular example, I've got a Spock test. If you haven't used Spock from the Groovy world, it's a kind of groovier version of JUnit. Same kind of principles apply. You have methods that are tests. So here I have a test for my corporate plugin. I use Project Builder, which is part of the Gradle API, to get a test project instance. So it's just a dummy project instance that's completely blank. I have that. I want to apply my plugin to the project, and then I want to build a bunch of tests. So this test here, I want to test it after applying the plugin. I have a repository installed. Then I'm going to go and try and add a new repository, but I expect, because of our rule, that it will not have been allowed to take. So we still will only have one repository. I'm testing that behavior. In this case, I'm testing that if I apply the plugin by itself, there is no intake test task. But as soon as I apply the Java plugin, that configuration that was in that plugins with type Java plugin block fires and adds our intake test. So any Java project is going to have an integration test set up. So once I have that on the class path, I don't have to apply it from a path anymore or a URL. I can just apply it by name. And you would have done this, of course, when you're applying the Java plugin or any kind of plugin that ships with Gradle. And the mechanism that makes this work very quickly is that on the class path, it's looking for meta-inf/Gradle plugins name of plugin.properties, and then just a pointer in there to the implementation class. I don't want to go too much into that. That's explained in the user guide, and I'll be talking more of that in detail in the upcoming plugins webinar that we're yet to schedule. So I have that as a jar now, and I can apply it that way. Let's just quickly verify that it works the same way. So now if I run Gradle, let's run Gradle classes. You'll see in the output I have this build src. That's Gradle seeing the project and implicitly compiling it and making it available for us. And then when it runs, you see our rule kick in here. So I won't bother showing it that the rest of the rules apply. You'll just have to take my word on that. So that's a build source plugin. So it's an object plugin embedded in the project. So that might be a good next step. Once you've got your standards defined and script plugin, and you just want to start thinking about sharing them, you can still develop them locally in the original project, but you can start to make it look like an object plugin. Then at some point in time, you're going to want to... So Frederick is asking if a bug in applying plugins in unit tests using the name, if it's fixed. The answer is no, that bug is still not fixed yet. If you didn't notice, 1.1 went out today, and the fix for that is not in 1.1. I'll be very surprised if it's not in 1.2 though. Okay, so that was a build source plugin. Some real estate back. Right, so now what we've done, we have exactly the same code that we had in our build source. We've just gone and moved it into its own separate project. So I now have two completely separate, distinct projects. And I've changed this is the build.gradle for the plugin project. I've added some uploading to it. So I'm now going to publish this to a Maven repository. I'm going to publish my plugin jar to a Maven repository. Instead of pushing to HTTP for the purpose of this example, I'm just going to push to a file-based repository. So let's go ahead and do that. I want to CD in there. Plugin, should run Gradle, upload archives. So that has gone and published my plugin jar. To my makeshift Maven repository on the file system. So now that I have that, I want to apply it to my project. And it looks the same as before in terms of applying it, but I need to add a little bit of extra code to get it onto the class path. So this is how that works. Inside the build script block, I declare where dependencies can be resolved from, and I add the definition of the dependency to the class path configuration.